Hello everyone. Have you ever struck a bell and noticed that the sound fades away slowly instead of ringing forever? That's damping in action. When a body vibrates in a medium, its amplitude reduces gradually because the surrounding medium resists its motion. These are called damped vibrations, periodic vibrations whose amplitude keeps decreasing until the motion eventually stops. A tuning fork vibrating in air or the sound of a guitar string dying out are classic examples. Nature reminds us nothing vibrates forever when resistance is around. Now, let's peek into what's happening behind the scenes. In damped vibrations, two main forces act. First, the restoring force, which always tries to bring the body back to its mean position. Second, the resistive or frictional force, which opposes the motion. These two forces work against each other, one maintaining the vibration, the other stealing away energy bit by bit. And the result? The amplitude steadily shrinks with time. It's like running while carrying a heavy backpack. The restoring force is your energy, but friction is the weight slowing you down. Here comes the most important observation. Amplitude does not stay constant, it decays with time. In fact, the reduction often follows an exponential pattern. If the initial amplitude is A, then after time t, the amplitude becomes A equals A multiplied by e raised to the power of minus kt. Here, k is the damping constant. The bigger the k, the faster the amplitude fades. At the same time, the vibrational energy is also being drained away into the medium as heat. That's why after a few seconds, your guitar note becomes a faint whisper. Once you understand damping, you start seeing it everywhere. Strike a tuning fork, it hums, then fades. Hit a bell, the ringing dies down. Even guitar or violin strings lose their loudness because air resists their motion. Car shock absorbers are a clever engineering use of damping. They reduce the vibrations of the car body, giving passengers a smooth ride. So, damping is not just about sounds fading, it's about comfort, control, and stability in everyday life. Let's take a deeper look with a formula. Suppose the initial amplitude of a vibrating body is a knot. With damping, the amplitude at time t is given by A equals a knot multiplied by e raised to the power of minus kt. The constant k tells us how quickly the vibrations die out. If k is small, the vibration lasts longer. If k is large, it disappears quickly. And remember, since vibrational energy is proportional to amplitude squared, the energy also drops rapidly with time. That's why a tuning fork in air stops after seconds, but in vacuum, it could ring much longer. Let's recap before we sign off. Damped vibrations are periodic vibrations whose amplitude decreases due to resistive forces like friction. Two forces are always at play. The restoring force keeps the vibration going, while the resistive force reduces it. Amplitude falls exponentially with time, given by A equals A multiplied by e to the power of minus kt. Energy is lost as heat to the medium. From tuning forks and bells to shock absorbers, damping is everywhere in daily life. So the next time your guitar string fades out, remember, you're listening to physics at work.